Alright, here comes more related concept, graphs. That's you often see in math, but not every graph, not every plot of points demonstrate a function. People think when they see curves and lines, they call them, oh, this is a function graph. How do you know that? Again, this is the check. You need to have only one corresponds to each x, such as I have number 2 here, and that number 2 is corresponding to number 2. So this is the 2, 2, right? How about 0? Think about 0. What is 0 corresponding into? There are 2 correspondence to 0. This one is 0, 1, 2, 3, and this one is 0, comma, negative 1. So kinda your 0 is going to 3 and negative 1. Is this possible? Can you pick a number and it splits into 2 other numbers? Impossible. So I already know, no, that's not the, yeah, I already know the answer for part D. This is almost a function. Every other point is fine though. Look at this. This is negative 3, right? 1, 2, 3. Negative 3 is going to only positive 3. And negative 2 is only going to 1, 2, 3, 4. Negative 4. Every other point is fine except at 0. The point is going to, the input value or domain value 0 going into 2 range values, impossible. So this is a no. But let's first do part A, B, and C. Okay? Part 1 is, according to this graph, you are going to write the ordered pairs that defines the relation. There is a relation here. Everything is a relation. On a graph paper, when you are given a graph paper like this and with dots on it or pictures on it, it's a relation. Because it consists of dots. Every dot is a relation piece. Okay? So we have a relation here. But your job is, this is a graphical image. It's picture. You need to turn this into this format. We did here. You have to put it in the listing order this way. Couples, ordered couples, okay? So how do I do this? You need to start off with this and you need to start filling these up. Alright? But how many parentheses are you gonna make? You're gonna make a parenthesis for each dot. 1, 2, 3, 4, 5. 4, 5. And each parenthesis will consist of 2 dots. Doesn't matter where you start. Usually start with the most negative x coordinates. So start with from the far left point. Which one is the far left? Seems like far left. Can you read me the coordinates of this thing? Far left one. This one is 1, 2, negative 3, comma, positive 3, right? The next, negative 2 and negative 4. We put this down earlier. Negative 2, negative 4. And later, 0, 3, 0, negative 1. Right? 2 values, 0 going to. And the last one is 2, 2. This is it. That's what we are going to enter right here. Okay. Now here comes the domain. There are two ways you can do this. Either use the part A and only pick up the values showing up in the first components, -3, -2, 0, 0, 2. That's one way. Pick up the values showing up in the first component in each parentheses, or use the dots again. If you haven't done part A yet, use the dots and see where they fall into on x-axis. These 2 points will fall to the same location, and this one will fall here, and this one will fall there. Like x attracts all these marbles dots, and they all move towards x and collect it on x-axis, like the floor. And you let the ball drop to floor. Where do they drop? I see that this is -3, -2, 0, and 2. You see, just because two separate points dropping to 0, we're not necessarily gonna repeat 0. 0 is counted only once. Okay? -3, -2, 0, and 2. Although you have 5 different points on the graph, unfortunately we have only 4 values in the domain because of being non-function. It's a relation only, it's not a function. There is one dot going into 2 range values. Now we're going to get the range. Guess how I'm gonna find the range? There are 2 options again. You either count the values in the y coordinate, 3, -4, don't repeat 3, this is repetition because you already counted 3 once, -1 and 2. There are 4 different y values. Or how do you do it graphic on the graph? This time your y-axis is the attractor. Points move right or left and collect it on y-axis. So for example, this one is going to be smashed into y-axis somewhere here, and this is already on y-axis, and this bottom one goes towards the y. Okay, so there are 4 different values, 1, 2, 3, 4, as we guessed earlier. So let's count from way bottom to top, smallest to biggest. Smallest value is -4. -4. The next smallest is -1, and then 2 and 3, right? Smallest to biggest always. So we already know the answer for this part. It's not a function.